All right, so we've started the night by celebrating some really great work. And now I get to introduce someone whose work will really make you think differently about what's possible. So tonight's talk is called Materialism, Shaping Our Future Through Form and Matter. And our keynote speaker who is visiting us is Bergmann, FAIA, partner at Big Bjark Ingels Group, one of the most innovative and consequential architecture and design practices working today. He has spent over 2 decades at Big doing something that sounds simple, but is actually very hard. He keeps pushing the definition of what architecture can be, not just buildings, but systems, energy, water, transportation, urban resilience. He heads up Big's global business development, and the firm currently works in more than 20 countries. He's been central to some of the most significant projects in Big's portfolio. Perhaps one of the most striking examples is his contribution to the Big U, which I'm sure he'll talk about, a 10-mile coastal resilience plan designed to protect Manhattan from flooding. So architecture as infrastructure, design as an act of civic care. That's the kind of work that we're talking about. He holds degrees from the University of Virginia and UCLA. He's a licensed architect in many states and in Canada, and he's taught at Georgia Tech, Pratt, Penn, and UVA. He's an AIA fellow, a past board member at Van Allen Institute, and a juror on competitions around the world. And something that I find interesting about his career is that it's built on this refusal to accept the false choice between ambition and pragmatism, between useful and beautiful, between poetic and responsible. Big's whole philosophy is that those tensions are generative and not limiting. And he's lived that out at scale and across continents. And so for our students who are here, who are about to enter this field, this is the conversation that you're walking into. The decisions that designers and architects make about form, material, and systems in the world. They shape how people live, and they matter. So I can't think of a better person to introduce this evening. Please join me in welcoming Bergmann.
Thank you. So I switch. All right. Are you guys ready? Yes. We are going to go on a trip to a few countries, and we're going to also see a big range of work. What I loved about going through the hallways here was to see actually design being done spatially, product design, furniture design, things that you actually touch with your bodies and with your eyes. And I think the way that the school approaches design is actually the way that we also practice it at Big. And therefore, I think we're going to have some fun. So I'm going to go really quick, and we're going to venture, hopefully. All right, are we able to turn the lights down? Is that possible? I'm going to take you back to when I was sitting in your chair. This is me at sort of 22 years of age, and I was finishing my studies. That's Eric Owen Moss, a youngish Eric Owen Moss there in the front seat. And I had just completed a thesis where I felt that we were privileging sight in architecture schools because we always present vertically, and the jury is always sitting a certain distance from the work, and therefore you're always looking at it from a distance. You're not actually going up and touching the drawings or the model or any of that. And so I decided to just test out the theory. What if you actually laid out your presentation horizontally? What if you built a table and then built the chairs that the jury was sitting in? And what if the first thing that they actually had to do was to touch your drawings and your model? And then the actual project that I was doing for my thesis was something that was also considering different degrees of eyesight or the loss of sight, and how one begins to orientate themselves spatially or through through any place with the other senses being prioritized. And so that was kind of a study that then led me to graduate. This was after sort of 6 years of education. And then I had been sitting in so many dark rooms like this, and I had seen so many slides of different beautiful places that I was longing to go. And I decided to go on a 3-year journeyman kind of, where I was traveling around the world working as a carpenter, as a stonemason, as a blacksmither, and a glassblower. And that was to actually learn about the materiality of the profession that I was learning. And I decided to kind of like go to these places. I didn't have a job. I just went, one-way tickets or trains and buses, and I just showed up, and then I looked for either a roof over my head or a job or both. And I did that for 3 years through these different countries, some of which were just opening up late 80s, early 90s for folks. So here's a kind of a few images capturing some of those kind of trips. I happened to work in Mali on some adobe structures, in Hadrian's Villa, where we discovered the tufa tunnels that connected the kitchens with the different palaces around Hadrian's Villa. So this is Roman era. Stonemasonry and some sculpting of granite in Lithuania, and then glass blowing in Sweden, which I really, really enjoyed. And that glass blowing here in Sweden then led me to work actually with Dale Chihuly in Seattle for another 3 years. So my full sort of time of apprenticing in different materials actually lasted 6 years, 3 on the road, and then 3 living in Seattle, working in the atelier of Dale. And what's interesting is there's now a 30-year kind of, we went to Venice 30 years ago and built these like wonderful chandelier structures all over the city. And that now is a 30-year kind of retrospective that's happening these weeks, again in Venice. The beauty of glass is that you can either blow it really, really thin, but you can also cast it and make it really, really sort of thick and use sort of optics. So here's another few images of Venice. Then I also traveled with him to Jerusalem, and we put a installation the year 2000 in the Tower of David Museum. And after these 6 years of working with different materials, I kind of was wondering, how do I now bring this kind of materiality back into architecture? And that's when I decided to attend my first ever architecture biennale. And so this is like 2002. And the architecture biennale is a wonderful place where all of the designers and architects around the world come. Typically for 6 months is the exhibition, but right at the beginning there's like 2 or 3 days which are called the opening days, and that's when all of the folks that are exhibiting are actually there. And when you're just a student, or you've just done a few of these things, and you're just trying to kind of like enter into the profession, incredible. You can go there for those few opening days and meet both the people that you've been looking at, inspired by, and you can also learn a lot from talking to folks. And that's where I met a very young Bjarke Ingels and Julian de Schmidt. They had an office called Plot, P-L-O-T. Now, why would you ever call your office, an architecture office, Plot? Well, guess what? You need a plot of land in order to have a building, a site, plot. And at the time, not so much anymore, when you did drawings, you plotted them out on a plotter, right? So plotting drawings for a plot of land. And what Bjarke and Julien always felt is that in order for a project to really mean something, it needed a plot, a narrative. And so the idea of marrying word with drawing with sight kind of really encapsulates kind of how Big and Bjarke sort of think about the world. So I met them there. They were still together. They then decided to split apart and start two separate offices. Big was the one that I joined with Bjarke, and then Julien de Smet opened up JDS later. So I've been with Big for 20 years and have been kind of working in Denmark, Copenhagen, then moved to New York 15 years ago, where we opened up in New York. So this is our office in New York. Open sort of plan. No one has an office. It seems very similar to some of the rooms that I was sort of poking into. You can see that the model making and the kind of scraps of paper and just sort of the ideas. So we're about 150 architects in New York and 850 globally. So it's a fairly large office. And so I want to get back to the idea of materialism as not something that is driven by consumerism, right? We think of materialism as something that you buy. This is the idea of materialism going back to the essence of what buildings and objects can be built out of. And that actually one of the most sustainable things you could ever do is to actually look at the materials that are around you or within, say, 100 miles of you, and that if you start to build out of those materials, that's a much more sustainable approach to architecture than to use global supply chains and bring things from halfway around the world and source things. So industrialization and modernism, in a way, has driven the cost of building from both the operational energy, but even more so the embodied energy of where do we source materials from to build our buildings. That is the cost that we need to address as a society and as a building culture. So we believe that this is not only about doing the things that people were doing for millennia, which was to build out of the things right in their backyard. It is also the smartest and sort of most intelligent way to build in the future. And we were lucky enough to be asked by Domos. I hope this magazine is in your library, but Domos is a 100-year-old magazine from Italy that allowed us for 1 year. We were able to kind of curate it. We were the editors, guest editors. So we used the 10 issues, because in Italy they don't work in August or December. They take it off. And so we had 10 months that we were able to curate, and we decided that each issue would be a different deep dive into a different material we use in architecture. Stone, earth, concrete, metal, glass, wood, fabric, biophilia, the immaterial, and the reuse of objects. And so you can see here, just as I just mentioned, these wonderful materials that you guys are also using in your models and you're learning about as you enter into the profession. And it really allowed us, it gave us a chance to really think about, we looked back at sort of the 20 years of work that we've been doing and thinking about what is it about each of these materials that is unique or important to us, but not through our own work, but through the work of others. So by looking at stone, we looked at the history of stone as a building material. We looked at where different types of stone actually exist geologically. We looked at the different structural kind of buildups of between granite to marble to limestone. So they all have different attributes. We looked at ways of working and finishing the stone. Take a look at this. This is structural stone making the arch, or look at that wonderful stairwell that just seems to be hovering in space. and looking at ways of reusing stone because it's such a solid material. A stone cathedral that's been under construction 140 years, and it will be finishing this year. Gaudi's cathedral in Barcelona, a 140-year construction site. And when Gaudi designed this, they hadn't even made the machinery to actually make the stone like he had drawn it. So it's as if the technology had to catch up with the designs, if you're talking about designing for the future. So it's only now that we can actually finish those designs that he had made. How new designers are using stone in a very fresh sort of way. And then following the stone from its origin quarry through to the use of this beautiful marble, Carrara, in the Perelman Center, Performing Arts Center. So, and oftentimes architects are limited in the way that they're thinking about materials because you have to, of course, follow rules and regulations. So artists are free to really kind of delve and discover. So we capture a lot of sort of artists using stone. These are big chairs that swivel. They're sort of like almost light. Your finger can just push them and they swivel around. These that look like cushions, pillows, but are actually travertine. And thinking of stone in very different ways than we typically would think about it. So then we also asked the artisans, the people who work with these materials, to actually help us make all the covers. And here you have a lovely smoking fellow who's making the Domos stone cover. Here's a clay artist that is making the earth cover with baked terracotta. And you can see how many different types of treatments you actually get. A concrete worker that's making the concrete cover and metal. So now I want to kind of switch gears because that 1 year of curating that magazine gave us a real in-depth view for these 10 different materials. Now I want to take you through and show you how in our own work we actually also work within materials and they become the drivers of the design. So we're going to start in the Arctic Circle in the northern parts of Sweden. There is this lovely family who have for a decade been inviting different architects to build tree houses in their backyard. I mean, what a cool kind of project to get. So they've been building kind of just one single kind of bedroom up in the treetops. We were the 8th architect that they called, and this is their backyard, and you basically now can Airbnb rent these tree houses for a night or for a week and hang out. What most of the tree houses, as you can see here, do are they're just kind of UFOs or kind of incredible objects. I think some of these things I've actually seen in the rooms that you have here. They could very well be in the Arctic Circle. But we decided that since most of these bedrooms or kind of treetop dwellings are built for people, we decided why not actually see and expand this idea for all species. So we looked at what kind of animals live in this forest. And you have bobcats, birds, moose, wolves. So we focused kind of on the birds and we designed a bedroom in the treetops surrounded by 350 birdhouses. So you basically are sleeping every night with the bird song. You walk across a bridge, you enter into this lovely bedroom. You have windows all around so you can see up and down. And just outside are basically your roommates. And this is just to show that, at any scale, you can create something that is quite extraordinary. This is the project of all the projects we've ever designed that has had more kind of clicks or more recognition. I think 1.4 billion people had exposure to this project around the world by just looking at the images. So you never know. Whatever it is that you do, it can have a profound effect. So also in the vein of wood, this is something that you should be familiar. This is Corbu's domino house. And this was a kind of concept at the kind of start of modernism where new materials were suddenly being used. Reinforced concrete, large panes of float glass or flat glass. These were not available really before then. And so this idea of this free room as opposed to a building with a bunch of rooms, right? This is kind of like more of a warehousey kind of idea, and you just put up partitions in that space. You really are just looking at making a column grid and a stair, a fire stair that takes you from top to bottom. So it's taking architecture down to the sort of essential elements. But we hadn't really thought of a sustainable approach to modernism or the domino house. And so we came up with a grid system or a prefab system out of wood that we call Pubo because it's being manufactured in Finland. Instead of a rigid square or rectangle, it's a wedge, like a piece of pie, a pizza. And what that allows you to do is it suddenly allows you to go from just bar buildings, double-loaded corridors, to suddenly designing things that are perhaps a little bit more organic and can actually fit into different sites. So the other idea that we had was that rather than just building one on top of the other, which is very typical in prefab construction, what if we pulled the prefab elements apart, creating a porosity? And the beauty of that is that when you consider it, each element that's prefab, which is the darker square, by pulling it apart, you actually create space, right? You have a roof, a floor, and 2 walls that you get for free by pulling apart the prefab elements. And this is a standard prefab kind of project here, very efficient, very rectilinear. That's the same project built for the same price, but it gives you a lot more space. Same number of units. So what's nice here is that it gives you the chance to actually design the site, not just putting a building straight down along the street. You can blow out certain of these prefab units so that you can create connections in the city. You can do a curve so you suddenly have a forecourt and a backyard that way, instead of just a building with a backyard. And take a look at, this is the space you get kind of for free, which is like a very generous 12.5 to 13 foot ceiling with the 2 bedroom pods on the left and the right. So it's about building in a way efficiently and affordably, but also maybe designing something that has a really high quality so that the people are actually very excited to live in affordable housing. And you can see here, these are the terraces where you're just pushing the storefront that would typically be right on the wall treatment, the facade. You're pulling that back to get the balcony, and then it's just a galvanized railing, really, really inexpensive metal rail you would find on the edge of a federal highway, and that's your balustrade. And to just show the kind of versatility of this system, that is the same system, but now in a spiral. And here, the spiral actually allows you to collect all the rainwater that hits the site. And the most incredible thing about humans is that we love water. So looking at water is more enjoyable than looking at dirt. And thus, any building that is next to water has a higher value. So imagine that we take rainwater that's for free and we push it down underground, and it just causes problems all over the place. We could just, in the same way, build retention ponds, have the water come into the ponds, enjoy the water while it's there, and it naturally evaporates. And then you don't have to invest in all of the underground canalization. So you've heard of stormwater, you've heard of like floods and things that happen because of all of that. So there's also ways that we can actually think about the way that systems and cycles work so that we can actually take better care of our planet by actually, integrating evaporative retention ponds when we can into our projects. And then we call up the city and say, guess what? You don't have to spend as much money on the stormwater because I've taken care of that on the site. And then you can negotiate with the city to find out how you pay less taxes, right? So there's a lot of sort of ripple effects in the way that you could approach site design in a project. Some more pictures on the inside. And then I wanted to show you, since this is the School of Architecture and we're still in wood, this is our proposal for the Kansas University Architecture School that is getting built. So it's now funded, and it's starting with this wonderful group of other collaborators. Here you have the current School of Architecture in this historic building to your left, and a 1970s building to the right. And they need a lot more studio space. So what we're doing is we are historically preserving this project. We are adaptively reusing and reshaping the 1970s project, and we are adding the cube, the wood cube, there in the center out of mass timber. So now this is a campus of 3 buildings from 3 different eras that will be kind of the centerpiece of the school. It's 6 stories, and it's 100% mass timber. And you'll hear mass timber being used a lot. And when it's used, you should ask, well, does it have steel in it? Because then it's not a mass timber project, it's a hybrid project using wood and steel. Most often the steel is there for all of the forces that the wood can't endure. But what we wanted to see is, could we create a 100% mass timber project? Because it's been done at different scales, smaller scales, not at this scale. So here you can see a few renderings, and the space has this wonderful stair that leads up. There's studio spaces that look down into each other. And here's the structural principle, which we have worked out with StructureCraft. And they are essential in having both the architecture and the engineering actually work. A few of the structural diagrams that show you which walls are actually performing which of the jobs. Now, I realize that this gets quite technical, but as students of architecture, it's really important that we open ourselves up and work collaboratively with engineers, because we need to understand how the engineering, the shear walls and the cross bracing and all of those things will actually affect the spatial solution. So this is where you take all of the structural ideas together, and then look at the stair. The stair is this like really interesting thing where you have a top stair in blue, which is just your basically stair that leads you open air from the top of the floor down to the ground floor. But it also needs to have a fire stair, right? So underneath the blue stair, believe it or not, is another stair that's fully enclosed. So that's your fire stair. And because of the thickness of the wood, the charring that happens during a fire, this is actually rated the same way that if you put 2.5 or 2 layers of gyp and you fireproofed and did all of that, this is actually performing better than what we would typically do for fire stairs. And this all had to go through kind of regulatory approvals, and we had to show how this was working. We had to fire test the different constructions. We had to go into the weeds. This is how you do kind of change the needle in terms of building things. And I'm so excited to say that this is going to be a school of architecture in about probably about 3 to 4 years. This is how we get the wood on wood connections with no metal. So we're using Japanese carpentry and using the kind of CNC machines and grouting machines that allow you to get that kind of a detail. So this is with StructureCraft, who are both the engineers, the fabricators, and the installers. It's very rare that you would be able to find all three of those things in the same group. This is a one-to-one mock-up that was built for just one corner. And then this shows you the actual joint. And this was at the Mass Timber Conference that happens every year in Portland. Now, I saw a bunch of incredible car designs out there in the school, so I put this one in here because we all know Toyota as one of the largest car manufacturers in the world, but they had a kind of issue. They came to us and they said, you know, architects, when they show the future of the world, there are no cars, there's only bicycles. They're like, what's up? What happened to all the cars? Why can't you guys put cars in your renderings? And you know, help us understand what the future of driving could be. So this is Toyota-san and Bjarke at the Consumer Electronics Convention in 2020, I believe. So this is the idea, is that in a typical street, you have sidewalk, bicycle path, and street all connected and all, you know, in the same place. So what we're saying is, what if we actually take each of those three different mobilities? Autonomous vehicles has one street. Electric bicycles and scooters would have a secondary, kind of another street. And pedestrians walking and strolling would have a third street. And instead of having a grid within cities where all three are always combined, we actually separate them, so that New York would have certain streets that are just vehicular, others that are just scooters and bicycles, and third that is just walking. What if you actually thought of that grid having those three different movements still being able to access and deliver to each of the sites, but that you actually now create safer corridors for different speeds of movement? And what if you start doing that actually at a city scale? So you create plazas, you create little parks, pocket parks, and so forth. And Toyota basically allowed us to take a 1960s car manufacturing site just at the foot of Mount Fuji, and to start planning a new way of building a city using their technologies of autonomous vehicles, robotic movement of drones and delivery systems, and e-bikes. And we created a vision, again, using Japanese wood architecture principles to create sort of laboratories to test out new technologies, to kind of create a kind of exchange, multidisciplinary kind of locations for people to exchange, and to create living opportunities for multi-generational housing that would all be testing. So this, we presented the idea in 2020. In 2021, there was already the groundbreaking, because they move very fast, both in Japan and in the car industry. And this is the vision at the foot of Mount Fuji. And this is what's built. The first 12 buildings are already there, and the streets are there. This is a year old, so this was within 5 years of the concept. We were able to already have the phase 1. Phases 2 and 3 are what you see in the background there, and a construction site from when that was construction. So it's literally a laboratory for the future of mobility, some of which I saw also in the hallways here of those autonomous electric cars. We're going to go to glass. And in glass, we worked with Google on their headquarters in Mountain View. And the interesting thing here is that when Larry Page, one of the co-founders of Google, he was trying to hire an architect to build the headquarters, he literally said, you know, when engineers have a problem, They stick 10 engineers into a room, and they collectively solve the issue. When you, architects, start to design things, you like to do it individually, and then it's your idea. So there's a little bit of ego in the making of a project. And he wanted to test out his theory that if he actually hired multiple architects and that we had to work collectively together, that he might actually get a better building out of it. So 3 architects, Big, Heatherwick, and Adamson, actually all had to work together to design about 5 million square feet for Google in Mountain View. And this is now all built and taken into use. And what you can see there, what we developed were 30 new building systems, one of which was the roof tile, which is a photovoltaic tile that actually generates 40% of their operational energy just from the sun. And maybe the difference from your grandparents' solar tile is that instead of this kind of rectilinear kind of contraption that looks a little ugly up on a roof, might have a huge tank underneath to kind of take all of the solar power and harvest it. These are wafer thin. They can actually bend if you just attach them at 2 points. And thus we can actually create swoopy kind of curves on the roof. And they are better performing than the solar voltaics from the past. And then in the back, it's a very small back of house that they actually have, and they connect straight into the electrical system. So these are what you basically work underneath. These are like what we call the handkerchiefs. And there are 3,000 Googlers working right there, basically probably all on Gemini, because this is where the AI team is working. And what Larry Page wanted was, if any of you ever heard of Burning Man, he wanted to basically have the playa where all of the different camps of Googlers were, and then he viewed the sky as sort of clouds passing across, and he wanted to be able to see everything from one vantage point. So, and then rather than, he also said that innovation doesn't happen behind a screen, it happens when people meet each other. So the stairs are never straight shot. The stairs are always kind of places where you can hang out, sit down, meet people. So it's really wonderful when you start to think that any element that you think is typical can be unique, and you can start to use those as the shapers of your space. We're going to go straight to metal, and here we're going to go into New York, and what brought us to the US was this project in New York called the Via 57th. It's 705 apartments on the west side of Manhattan. And typically you have a skyscraper in New York, and in Europe you have courtyards. What if a skyscraper married a courtyard? Well, you get a court scraper. And that's basically what we created. It's low, 4 stories on the water side, and moves up to 44 stories on the city side. And then all of the folks have this wonderful garden that's on the 2nd floor that they can use, which during COVID became actually, this is the building that everyone was trying to get into during COVID because it had that generous space. So just like Central Park acts as this wonderful release and relief of the city, so too does our courtyard. It's just 13,000 times smaller than Central Park for 705 apartments. And the width here, interestingly, is the same width as a city street, 60 feet. So if you can live across the street from people and look into their windows, that's literally what you're doing here too. And then within the park, you have a wonderful array of different spaces. And imagine living in Hell's Kitchen, New York, and you're living in a 1-bedroom apartment, you got birds tweeting outside of your bedroom window. So a pretty unique experience within the city. This is Copenhagen. And what you see there on the horizon is a waste-to-energy plant built out of mostly steel and metal. Waste, one bag of household waste is equal to 4 hours of electricity and 5 hours of heat. So this is the biggest building in the history of Denmark, the tallest in the flattest country of Europe. And since Scandinavia, Denmark has snow, but no mountains, we take the mountains of trash and we place a artificial ski slope on top of the trash incinerator. So the trash incinerator functions like any other incinerator. It has a lot of kind of furnaces that take the household waste, burn them, and then in the process create the energy. But on top of it is an artificial plastic, recycled plastic, skiable surface. So you can basically come up to the top, put on your skis, and then enjoy a lovely ski down white trash. And the Danes have never been in a downhill team for the Olympics. They only do curling. So this is their chance to actually build the freestylers and the extreme skiers of the future. It also has the highest climbing wall at 100 meters. It really requires a lot of confidence and skill to be able to climb 100 meters high. And it's become a little bit of a postcard kind of moment that a trash incinerator has as much kind of value for the city as the Little Mermaid here in the foreground. We're going to go to concrete. So our own headquarters, we took as a time and an advantage to actually test out different materials. So this is a concrete that actually uses 30% less carbon as a traditional typical concrete, because we believe that not everything can be built out of wood, which is a nice material from a carbon standpoint. So we will actually need to be smarter about concrete and steel, and we should be doing as much research as we can building from those. We also did the landscape and brought back many native trees. We brought back a sandy beach into an industrial kind of harbor. We have 6 floors, similar to that architecture school that I showed you, but just a completely different system. We engineered this building. We also actually own part of the contractor, so we also built it. So we designed it, we engineered it, we built it, and the furniture is also designed by our product designers. So that's a very holistic way of actually thinking about how Lawrence Tech could also do all of it if you guys wanted, and just stay together. You don't even have to graduate. You could just open an office next week and start designing things for each other. So this is a Piranesi-like stair that reaches up to the top. We have only one column in the entire building, which is a stone column, and it has no metal reinforcement. All of the weight of the floor above rests on that stone column. And then we chose 6 different quarries in Scandinavia, so you have 6 different colors of stone. So it's a little bit of a catalog. If you're going up the stair with your client, you can say, well, you can have green or blue or white, and they can decide which of the stone colors that they would like in their own place. And then on the top, we have this 6th floor room that is really for us to just both have parties or to celebrate big wins and to, again, get outside and enjoy the views to this wonderful harbor space. We're at the tip. Also concrete, this is a 3D printer, and very much in the future, we're going to be basically seeing homes or small dwellings 3D printed. with a sort of cementitious fluid material that kind of hardens as it's actually coming out. And you can see it here. It's just incredible to see, just within the 8 years that we've been working with it, how many advancements have already been made. We designed 60 different house plans for the technology. You can go to the website of Icon Build and choose one of these, and then you could arrange with them to bring the printer, and literally in about 14 days, 20 days, you would have a printed home turnkey to walk into. So then there's already examples of homes here. It's 3D printed walls, but traditional wood framing for the roofs. In the next iteration of this, the roofs will also be 3D printed. And then also providing affordable housing in places where we're bringing the construction cost, the hard cost, down to about $60,000 for a 2-room home. With the same company, Icon, we're working together with NASA and the Artemis rockets that just went to the moon and back. And we're designing spaceports and habitable spaces on the moon, printing with the moon dust, the regolith, on the moon. That's the building material. And then the printer is just basically taking it, because it has a silica. It's actually made up of obsidian. And there are examples already in Houston where they're building and testing how this is going to happen. This is a picture of some tests that were actually done with Icon. And all of this is actually funded through NASA a few years ago at $60 million. So hopefully tax dollars well spent. Biophilia. So it was said that I work at a scale of the city and resiliency. So this was New York 2012 after Sandy. So now 14 years later, we came up with an idea to raise the edge of Manhattan to protect it against sea level rise. And this is not new. New York has been expanding and raising its edges for centuries. So this is in blue, everything that was flooded during Sandy. 200,000 people were homeless, $19 billion of damage just to the city of New York. And so with, again, a huge group of many, many different kind of specialists, and taking over hundreds of community meetings to hear what the community wanted and needed, we came up with a kind of solution that we call social infrastructure. So typically infrastructure is done by engineers, and it's done very rationally. How do you get from point A to point B the quickest? We were kind of looking at how can you create infrastructure for people and think about the activities that the people actually enjoy. So we infused the infrastructure with side benefits, kind of win-win. And we make it and change the uses based on the different neighborhoods and the different kind of people who are living there and their needs. We also can't just build one continuous 10-mile long kind of solution. So we break up the solution into segments that are fundable, buildable within sort of 5-year segments, and create something that can be done in one mayoral cycle. So that's a lot that I just said. We have 6 clients, not one. One's already hard. So imagine 6. And they don't like each other. So Department of Transportation builds roads, and they're like, why is Department of Parks here? You know, they like trees. And so trying to get the parks and the transportation departments to actually move in the same direction is pretty hard. But that is the kind of, that is to me also like design. This is also how one actually, manages and navigates that. So the first 2.5 miles is called ESCR, East Side Coastal Resiliency. And you can see here, it's the size is 62 acres, compared to other parks in New York. And this was our vision. We call it a parkapelago, an archipelago of parks. And you can see here there are little programmatic uses in each of the little islands, and it's built. So voila, 14 years later, it's there, and people are actually enjoying it. It is raising the edge of Manhattan about 8 to 9 feet, and people can now rest that they're not going to get flooded out of their homes. Kids are loving it, and there's the different uses from soccer fields to baseball to tennis to multi-generational to a music park, so something for everybody. And again, it's an idea that if you remember Katrina in New Orleans, they built a dumb gray wall. They basically built a wall that everyone looks at and hates. This is an idea that you use the same amount of money that was spent in New Orleans to build a wall, and you use it to build a park that everyone can enjoy every single day, and it's not something that you look at and hate. So that's the idea, is that this park is viewed as something that provides more benefits. Earth. This is our latest project, just completed a couple of weeks ago. It's called Not a Hotel, but it's a hotel. It's in Japan on these islands, and it's a small sort of 3-home kind of design that is a 90, a 180, a 270, and a 360. Very, very simple. Each of these homes is actually built to bring the old Japanese traditions into the new world. So instead of soji screens, we have glass screens that open on a curve. Instead of these clay tiles, we have solar tiles on top that generate electricity. And instead of earthen walls, we have rammed earth walls that have been stamped using the earth from the site. So it's kind of a Japanese tradition, but brought into a kind of new world. These are not renderings, these are images. Bjarke was just there and enjoyed it immensely. So next time, Airbnb, Japan, you got a destination. This is in China, just because I told you we're going to travel around the world. This is a museum of natural history. So we have one in New York, and that's where Night at the Museum, the movie. So this is the Chinese version of Robin Williams riding a horse through the museum. But here you have 8 different galleries that are all showing different epochs of history, natural history, within China. It originally is with the street grid over here on the left, but then it migrates to the river direction there on the right. And we use terracotta, a very Chinese kind of material, to use and build the twists of the galleries. And this is, again, something that has to be really, really worked hard in order to create that kind of seamlessness that you see there. But these are all baked in the kilns and the ovens. They're all made as kind of pieces that you can carry with 2 hands and then assembled onto structure. But this is something that it's under construction at the moment and will be done, I think, by the end of 2028. And we're getting to the end, but we're going to now combine a lot of that materialism ideas into a single project. This is Bhutan. Bhutan is small country sandwiched between China and India, but 70-80% of it is forest. 90% of it is mountainous. So it's very hard to build. Wonderful culture built on Buddhist principles. One of the things, it's a monarchy, so there's a king, and it's been ruled by a monarchy since for centuries. And there are 800,000 people. 80,000 people have left in the last 10 to 15 years. And the king was just thinking, if that continues, and they're typically younger people who don't see a future for themselves, then I will not have a country in my lifetime. or I will have a country that I can't sustain because of the inequity of age. So he's asked us to basically design a new city from scratch for 80,000 people, same number that have left, but to do so that we actually show what the future of Bhutan can be. And he asked us to design this city on the values of Buddhist philosophy of mindfulness, compassion, wisdom, inner peace, togetherness. So very different than Western values that you would typically have. So it's called Galefu Mindfulness City. You can see here it's between 3 billion or 3.2 billion people. So it's a tiny little country there in white. This is what that new city area looks like. So it's very farm-like at the moment. This is the 80,000 sort of person density. And these are the materials with which we're going to work. Bamboo, wood, earthen bricks, and stone, river stone. These are the typical ways that the current Buddhist architecture is built, made up of sort of stick-built construction, and they have a very strong identity. They build typically 4 and 5 story buildings, and we're learning from those kind of principles. They also have never really had architects. They've done most everything with master craftsmen, teaching other apprentices and pupils how to build. And so we're both looking into the past to learn their traditions, but we're also looking for ways to actually turn this, like in the Japanese house, into a sort of modern interpretation of the past. And so we're looking at a lot of different scales and different sort of courtyard to sort of object buildings, and at different neighborhood configurations. So from the mountain, where things are built within the slopes and you don't have a lot of density, as you move down the mountain, the density starts to increase. And these are 2 and 3 generational homes where you have the grandparents living with the grandkids. And then as you move down the hills, things become a little bit more dense down into the actual sort of village or city of Galefu. This is all financed, believe it or not, by water. So they have a hydrological dam from all of the river water in the mountains. They sell the electricity from the dam to the Indians, and that's what finances what you've just seen. But instead of a dam, remember I used the word social infrastructure? Imagine a dam that becomes a pilgrimage of stairs as you can walk up the entire face of the dam to a temple there in the center of a lying Buddha. And so you kind of walk and allow the entire infrastructure to be a journey. We also are being asked to design the airport that, because it's the flattest part of the country, will allow people to come in. So this is based on Buddhist principles and Buddhist architecture, a airport built in the Buddhist sort of style with incredible intricate carpentry. The only issue with building in this way is that there are not enough carpenters, Buddhist carpenters in the entire country to actually build at this scale, because they've never built a building this large. So at the last Biennale, remember I mentioned the Venice Biennale, we actually took 2 Buddhist carpenters and they were carving the beams in the airport basically as a test. Next to the carpenters was a robot that was machine learning from the 2 Buddhist carpenters and learning how to carve Buddhist kind of styles and motifs into the wood. So on the right is hand carving. On the left here, this is not a split image. This is the same object. Is the robot. So it's a little lower res, as you can see at the moment. But the 2 carpenters basically see this as the only means, also because they see fewer and fewer apprentices coming to learn this. This is a way for the craft, the Buddhist craft, to actually live on. And so they are actually supportive of this idea of machine learning carpentry, which would then allow us at the scale that we are intending to build an airport of this scale. So the runway is under construction. The king is pretty happy with the way that we're working, and we're working with a lot of local Buddhist architects now to bring in the design principles, and it's really their project now to realize. So if you're interested in our work, here are a couple books. I was happy enough to be in the administrative office, and right there's the hot to cold book, and another one big. So you have a couple of our books in your library, and if you want to stay in touch, thank you so much.
Many gasps in the audience as you were showing your work. What an incredible, inspiring talk. Instead of questions, I want us to linger on thoughts of robotic carpentry and moon dust and I can't say it. So let's go enjoy the student exhibition, and thank you so much for such an amazing talk.
Yes, thank you.